My name is Per-Erik Strandberg. I'm a test lead and also industrial doctoral student here at Westermo Network Technologies AB. Today I'm going to talk a bit about my personal experiences and a research project we recently finished. So we just published a paper on the topic of information flow in software testing. This is an interview study that we did at a number of different companies, and the main findings of this paper is that the information flow in software testing can be described as a number of feedback loops of increasing size. These involve a number of stakeholders, source code, test equipment, and in addition to these feedback loops, one of the main findings of this paper is that good and close collaboration and communication between roles is essential for having a good flow of information in software testing. The background of this study is that we at Westermo, we developed these embedded systems, switches and routers targeting harsh environments. That could be the rail industry, mining, different process plants and so on. These are environments that can have a lot of vibrations, they can be dusty, maybe there are dirty power spikes. Here we need, for the communication network, switches and routers that are robust, and consumer grade products are not good enough here. So we design and build them here at Westermo, made in Sweden, we're of course proud of that. And when we do testing of this, we have a complicated, advanced test setup, and we feel that we didn't really understand all the aspects of the flow of information in software testing. So we did this interview study together with people at the university, and we just published this paper. It came out now in April 2019. The title is Information Flow in Software Testing, an interview study with embedded software engineering practitioners. It's written by me, Per-Erik Strandberg, Edward Paul Enoyu, Wasif Afzal, Daniel Sundmark, and Robert Felt. Now, this wouldn't be research unless we had a good method. And we made an interview study. We interviewed people, we recorded the audio, we transcribed the audio, and we wanted to analyze these transcripts. And if you run some different experiments, maybe you get numerical values, and you can do statistics on that. That's straightforward. Here we have another type of data. We have qualitative data. So we did qualitative analysis on this. We followed a method called thematic analysis. We used guidelines coming from psychology. And what you do basically is you take these transcripts and you tag different parts of them with different themes and sub-themes. So in the end, you get sort of a mind map of all the interview data. And this will help you look at the data in new and interesting ways. And you can see things you didn't realize were there when you did the interviews. We went to 5 different companies. 2 of these build communication equipment. 2 of them build vehicles. And the 5th one does consulting in the safety critical domain. We interviewed 12 people, and they had an average of more than 14 years of experience. So these are very experienced people, practitioners out there in the industry who've worked for more than a dozen years. They know what they're talking about. They have seen the good things and the bad things. And most of them have challenges when it comes to the flow of information in software testing. The results from this study can be seen as 4 answers to 4 different research questions. The first research question is about the overall process, the overall flow of information in software testing. The second research question is on the topic of themes. So what key aspects have an impact on this flow of information in software testing? Third research question is on challenges. What are the obstacles for a good flow of information in software testing? And the fourth research question is on good approaches for enhancing the flow of information in software testing. The answer of the first research question, the overall flow of information in software testing. So you can see this process as a series of feedback loops. They start and end with the software developer enhancing or changing source code. So if we look at the start, at the right side of this flow, we have unit testing. So here a developer is sitting by himself running test cases without any hardware. So the testing is very rapid because there's no hardware involved. And the developer is triggering the test cases and getting the results in a very fast feedback loop. So you're not talking to anyone else, you're not having any hardware. This is a very simple and fast and efficient feedback loop. As we move a bit to the right in this process, we come to integration testing. And here is where we have hardware involved. Now we have maybe a part of an embedded system. Perhaps we have a complete device that we do testing on. And here we are sort of interested in integrating the software and the hardware and making sure that everything works. And now we need to upgrade the firmware. As soon as we change the software we're testing, we need to update the firmware in this device again. And this can be a very iterative process. We need to upgrade over and over and over again. Here, testing is a bit slower, and since you have hardware involved, this is slightly more complicated than testing on a unit level. And now, as we keep moving to the right in this flow model, somewhere around here we need to involve a testing team. And in our interviews, we saw 3 different types of testing teams. First, a team that does manual testing. But it could also be a team that sort of develops and maintains the test environment. Maybe they build the simulators and so on. And the third type of testing team could be a team that develops and maintains and has a responsibility of a test framework. So they sort of write the code that executes the tests. And now is where we reach the system level testing. Now is where it gets interesting. So here we need a test system. Maybe it's built in a 19-inch rack. Maybe it's built on a wagon. Maybe you have an entire vehicle that you can do testing on. Here it's complicated. There's lots of hardware, lots of different support systems. You need to turn power on and off. Maybe if you have a driver panel, you need to simulate buttons. There are all sorts of equipment here, signal generators and so on. Here is where we have really interesting testing. And finally, we could see that a lot of these companies use external testing as well. So this could be perhaps some beta testing by someone they trust at another site, maybe the company that buys the vehicle, or it could be acceptance testing by the customer. And this is a very slow feedback loop, of course, because you need to release the software, maybe a public beta, you upgrade the site, and someone is testing, and then you get the feedback. So that's the slowest of these steps. We can also see that in our interviews, many of these companies had a process or a gate that stopped the software that has recently been modified. They stopped it from reaching the test environment. And that might seem counterintuitive. Why would anyone want to stop the testing? So one of the reasons is that you want to have good quality when you do testing. So maybe you have to have a code review before the new code can reach the test environment. Another process that could stop the testing is when testing is expensive. Maybe it's manual testing, maybe it's safety critical systems. Here we could see a pattern that software changes are sort of stacked one on top of the other before the testing starts. And then when the testing has begun, there are a number of code changes being tested all at once. So instead of testing them one by one in isolation, everything is tested at once, because testing is a very scarce resource, perhaps manual. So once testing has been done in the test systems, we produce test results. That's where we get the results. They need to flow back to the developers. So there's a flow forward of modified source code, and the test results have to go back to the developers. So what happens when we have done the testing is we have produced the results. They go into perhaps a test results database, and then a developer would either be pushed, the results would be pushed to the developers, or the developer would have to pull the results. And if a tester has been involved and done the testing, and there's some kind of failure, then he or she might walk over to the developer and have a face-to-face conversation on, I saw this, something seems broken, could this be a bug? And this face-to-face communication is one of the standard approaches that we could see. It's a very important part of the flow of information in software testing. Another aspect is to file a bug in an issue tracker. But we could sometimes see that bugs that are filed, if the tester has filed them without communicating with the developer first, then when the developer gets the bug, it's missing information. So not everything you need is in there. So talking to the developer first and then filing the bug, that's a good method that we saw. We could also see that some of the testers, they're sort of afraid of filing a false positive. So they could spend hours investigating a failure before they file the bug because they're afraid of filing a false positive. So that could be a bit of a waste, but that's what we saw. And the results, when they are presented to the developers, sometimes we have a web portal to show the results. Maybe we have a visualization on pass and fail. Maybe we show trends in some different way. Another pattern we could see was that sometimes you want to be able to export from this test results database into another format. And the standard case here is a project manager that wants to look at test results in Excel. A very common approach when it comes to testing, at least in traditional environments, is to write a test report. And if you are in the safety critical domain, a written test report is extremely important. It's one of the most important artifacts in the development process. But in more agile environments, the value of the test report is sort of questioned, because a human being has to write the test report, or at least that's what we saw. And if a human being is writing the test report, there will be another feedback loop here. And once the report is written and can be handed over to someone, the information in it is old. So in these continuous environments, the value of the test report, the value of a human written test report is sort of questioned. Okay, so that was the answer to the first research question. And if we zoom out a bit and look at this, we can see that this is a series of feedback loops. They're getting bigger and bigger, and they involve more and more hardware, other stakeholders. Maybe the process has an impact on this. These loops have a different size and speed. And that's the answer to the first research question. This is the overall flow of information in software testing. The second research question is on the key aspects that have an impact on the flow of information in software testing. If you do thematic analysis like we did, this would be the themes from this analysis. We found a number of them, and I will only talk a little bit about some of them. If you want the details, you can read the paper. There's a lot of text in the paper. I can really recommend it. So the overall themes that have an impact are testing and troubleshooting, communication, how you communicate at the company, the processes you have, how the company is organized, technological aspects, and also artifacts. And I'll give you one example. So there was a big frustration because these feedback loops were always too slow. So at some companies where they had safety critical development, for example, the feedback loop between a changed source code, and the test result could be 2 months. Now, waiting 2 months is a long time, so they were, of course, frustrated about this. At other companies, they had a feedback loop of 2 hours, and they were as frustrated with this feedback loop of 2 hours. So regardless of how big these feedback loops are, people will always be frustrated about them, it seems. Some of them mentioned that, a feedback loop of 15 minutes, that's acceptable, but anything else is considered too slow. Now, one of the reasons of having a slow feedback loop is that these are complex things. We have a complicated, complex test environment. There's a big code base. We have compilation times that play a role here. And we have all these supporting subsystems. And this complexity also plays a role in understanding the root cause. So if there is a failure, it could be a problem in the simulator. So maybe we are emulating the environment in a bad way. Maybe that's where the problem is. Maybe the signal generator is incorrect. Maybe we're not timing the packets we're sending. The timing isn't by the millisecond, but it has to be, perhaps. It could also, of course, be in the software that we're trying to test. This is where we want to find the bugs, or we expect to find the bugs. Maybe the test cases or the test environment have the problems. So pinpointing the root cause, that can be really tricky, and this plays a role with complexity. I want to point out that some tools can really be helpful here, like doing different visualizations, analyzing log files, for example. But more important than tools is the close collaboration and communication between roles. That's the most important aspect of having a good flow of information in software testing. I also want to mention that we, in these interviews, noticed that a lot of these companies do test selection. So test selection is when you have too many test cases or too little time, so you can't test everything. So you have to make some sort of risk analysis or selection or prioritization of what you're going to test. And I'd like to mention that we wrote 2 papers on this topic, where I was the first author, one in 2016 and one in 2017. And I wrote these papers with Afzal, Sundmark, Ostrand, and Wayoker. One of these papers won Best Paper at a fancy academic conference. So if you want to learn more about test selection, you should check out those papers. And I want to point out that this is still a relevant problem for the companies that we did interviews at. Test selection is still important for embedded systems companies. The third research question is on challenges in the flow of information in software testing. Now, we could identify a number of these. There are a lot of details written about this in the paper. I will only mention a few of them. But the biggest challenge is comprehending the objective and the technical details of a test result. So we talked a little bit about this. And one of the problems is understanding the state we had in the test framework when a test case was executed. So did we have the same firmware as we had yesterday? Are we running on the same device? Is this a different device than the one we used yesterday? Did someone change a cable? Are we still running packets from the load generator at the same speed, and so on? So comprehending all the details of the surrounding systems is a very complicated problem. And this is related to the second challenges, and that's understanding the origin of a failure. And again, this has an impact with the root cause analysis that we just discussed. The third challenge is poor feedback. So the feedback is too late. Sometimes there's too little feedback, and sometimes there's too much feedback, so we get an information overflow. So whatever we're looking for is sort of hidden in an ocean of log files. Another challenge is that testing is sometimes postponed. And one of the reasons for postponing testing could be that we don't have the hardware ready. Yet another challenge is immature testing infrastructure and tools. And finally, I'd like to mention distances. So distances in the flow of information in software testing could be geographical, they could be social, cultural, or linguistic. So sometimes a software testing department is outsourced to a different continent, for example. That would mean that the geographic distance increases. You would have distances in time zones, so there would be a temporal distance. You also have a language barrier and a cultural barrier. Another example is one of our interviewees. A tester said that when this tester was modifying requirements specifications into testable test cases, it was impossible to understand the very technical English it was written in. So when the technical English was written, it would discuss a subsystem in this vehicle, in this case, and it would be impossible to understand in Swedish what this meant. So language barriers is an important distance in the flow of information. And I'd like to point you to two other studies that have looked at distances. One of them is from the year 2000 by Olsson and Olsson, called Distance Matters. And the second one is from 2016 by Bjarnason, Smolander, Engström and Runesson. It's called A Theory of Distances in Software Engineering. Both of these discuss these distances. And now we also discuss distances. Those were some of the challenges that we have identified in the flow of information. The fourth research question is on the good approaches in the flow of information in software testing. So the most important good approach to improve, enhance your flow of information would be to have close collaboration and communication between different roles. So for example, you could have a requirements engineer and a tester working together when writing requirements. This is a type of pair programming, if you like. But pair programming doesn't only have to be between developers working on source code. It could be on all sorts of artifacts in your software development process. And I strongly believe that all sorts of different roles, stakeholders could be involved in different types of pair programming. Another good approach is to have fast feedback loops, obviously. So how can we achieve fast feedback loops? Well, two ways could be to first start testing even before the hardware is ready. Maybe you could emulate or simulate or virtualize parts of the hardware to get the testing going earlier. Another way to get testing fast and early is to do informal or exploratory testing. So maybe you don't have the requirements yet, maybe you don't have the test cases yet, but maybe someone could go into the test environment and start working with a part of the source code to try to figure out how it works. Exploratory testing is a good way to learn about the system and to get the documentation work going, and also to find bugs you hadn't really thought of when you wrote the test cases. The third good approach is to have test reports automatically generated, maybe customized and also visualizing different trends. So for this to happen, you would probably need a test results database. And again, this could be automated, a lot of it. And again, I'd like to point you to a paper that we wrote in 2018. It's by me, Strandberg, and also Afzal and Sundmark. The title is Decision Making and Visualizations based on test results. So this is a paper that describes how we visualize and how we make decisions here at Westermo. And finally, I'd like to mention a good approach of having adequate tools and frameworks. So these should be suitable for the task at hand. And in the best of worlds, they are integrated, or at least they link to each other. So those are some of the good approaches and how you could, at your company, get a better, enhanced flow of information in software testing. We're getting to the end of this video. And to summarize, I'd like to say that I'm Per-Erik Strandberg. I'm a test lead and industrial doctoral student here at Westermo Network Technologies AB. This has been a video on the flow of information in software testing. We did an interview study. We went to 5 different companies and interviewed 12 different individuals. We transcribed the audio that we recorded and we analyzed it with thematic analysis. The 2 most important findings of this study is that the flow of information in software testing can be represented by feedback loops of different sizes involving technology, different stakeholders, and also the software development process. The second most important finding is that close collaboration and communication between roles is the number 1 ingredient for a good flow of information in software testing. In addition to this, we also looked at the key aspects with an impact on the flow of information, the themes. We also investigated challenges and good approaches. You might ask if this has ever been researched before, and of course it has, but from our perspective we see it as a bit of research here and there, and we did a study that sort of ties all of this together in this flow model. But I would like to mention one other paper. It's by Shaheen, Babar and Xu from 2017. This is a literature study on continuous integration, delivery and deployment. So check that paper out, it's really good. And for future work, we would like to use the results of this study to improve what we have here at Westermo. We want test results to be faster. We want it to be easy to explore test results. Maybe when you're looking at the test results, you're not really sure what you're looking for, but having this exploratory dimension to it might lead to epiphanies. You find things you didn't really know you were looking for. And we want a tool that's easy to work with. It has to be easy to develop and extend and maintain. And above all, scalable. Scalability is a big problem for us. We're ramping up the testing, we're investing lots of money in our testing, and the test reporting has to follow. We need scalability. And with that said, I'd like to thank you for your attention. See you next time.